Hello everyone. So the last practical concept under risk management is BSM, that is Black Scholes model. So in this concept we'll be solving the practical problems. So basically this model is used for calculating the option pricing. So we have four derivatives: future, forward, option and swap. So for this option, for calculating the value of the option in the future, what will be the value of the option? For ascertaining those returns, we can calculate it with the help of the BSM, that is Black-Scholes model, and this model is also known as Black-Scholes-Merton, and this is the first widely used model for option pricing. So in the world, this is the first model which is used for calculating the values for the option. And one more thing, the most important thing here, the options are carried out in two styles. One is American, another is European. So what is the difference between this American and European style? Means American style of option, we can exercise, we can purchase, we can sell those options in whole life of the option, that is before the expiry date. So optional ಅಷ್ಟೇ ನಾವು one date fix ಮಾಡ್ತೀರಿ. For example, 38th July, on 38th July I will sell this option to you. So this is the one date they have fixed. This is the expiry date for us exercising the option. So American style ನಲ್ಲಿ before coming the 30th July, in the whole contract life, you can sell your option whenever you want. You can sell it out on 1st June, on 1st February, whenever you have enter into the contract. From that date to the expiry date, within this period you can sell your contract. There is no compulsion on you that you have to sell it on only the expiry date, that is on the July 38th. But in the European, it is completely opposite of the American. So European style, in European style only on the expiry date you have to exercise your option. So BSM model is only for those options who are using the European style of option. So this BSM will be calculate the value of the option price with the help of the following factors, that is the stock price, expected returns, option stock price, interest rates, time duration, expiry date and volatility. This is standard deviation. So every model has certain assumptions. So this model is also having some assumptions. So first one assumption is, which we have already discussed, that is European. See, the for calculating the option pricing, the most important thing that has to be noticed is the option must be European style option, that is that can be exercised only on the expiry date. And one more thing, no dividends are paid during the life of the option. So when before the expiry date, the dividends is also not paid. Next is markets are efficient. Markets are efficient in the sense, whatever the movements, whatever the volatility that is happening in the market that are unknown and that cannot be predicted. So it means the changes, the constant changes in the market that cannot be predicted by the normal persons. Next is, there are no transaction costs. There is no transaction cost like brokerage charges, commissions, etc. Next, there will be risk-free interest rate, and the volatility by the experts will be noun and the constant. So volatility will be given by the experts and interest rate risk that should be noun, and the returns, whatever the returns that they are getting daily, that they are getting on the expiry of the day, will be calculated with the help of the normal distribution. Now comes to the formula. So this is the formula. So C equals Sn within bracket d1 minus ke to the power minus rt and d2. So what are these noun for? So let's see. C means call option, S means the stock price, K means the strike price, that is the price for buying or selling the option, R means the rate of interest, and T means the expiry of the contract, that is the option. Next, remaining things are D1. So here D1, for calculating D1, there is one sub formula, ln S divided by K plus R to the power of T divided by standard deviation root of time plus 0.5 standard deviation into root of time. So this is the formula for calculating D1. Next, the formula for D2 is, D2 will be whatever the answer you will get here after calculating D1, you have to less D1 minus standard deviation given in the problem into root of the time duration given in the problem. So S will also be given in the problem. In D1 we have to calculate it. K will be also given. E here means the log number, that is 2.718. R will also be given, time will also be given. D2 we have to calculate. Next, what is this N? What is this N? N here, it means the normal distribution. So ND1 and ND2, how to calculate this ND1 and ND2? So for calculating ND1, we need to take help from the normal distribution table. So this you will get to know while we will solve the solution. So the one more formula is there for D1. So same thing, ln sk, the changes is standard deviation to the power 2 is there and divided by 2. So we will use this formula only, which is the simple one. So let's take one problem. So problem number 1, we have to calculate the call option. So this is purchasing option using Black-Scholes model. So stock price, given stock price, that is S, they have given 90. Months to expiry, this is the T, that is 6 months. 6 months means 6 by 12. Next, they have given risk-free interest rate. So risk-free interest rate here means it is the small r, that is 8%, means 0.08. Next, standard deviation is 23, and excise price means the K, strike price is ₹80. So the option style they have mentioned here is the European call option. So now with the help of this formula, we have to calculate the value for the call option. So take this formula, SNT1 minus KERTND2. So given information, S is 90 rupees, T they have mentioned 6 months, 6 by 12, it means 0.5. Risk-free interest rate is 8%, so 8 by 100, it is 0.08. Standard deviation they have mentioned 23%, so 23 by 100, it will be 0.23. And the excise price is K, that is 80 rupees. So with the help of this information, we have to calculate the value for the call option. So call option equals Sn d1 minus ke to the power minus rt n d2. So first of all, for solving this equation, we need to solve first of all d1, what is the d1 and what will be the d2. So d1, the formula is given in the problem. Two formulas are given, you can take any one. So we will solve this by taking this formula. So d1 equals ln sk plus rt divided by standard deviation to the power t plus 0.5 standard deviation to the power to the square root of t. So here s, what is the s? S is rupees 90. S is rupees 90. Next, K. Next, K is 80. So d1 ln, write this as it is. S means it is 90. K means the given price, that is strike price is rupees 80. R, they have given 8%, so 8 by 100 it is 0.08. So T, they have given 6 months, so 6 by 12 means 0.5. So this is 0.5. Next, take same as it is standard deviation. They have mentioned 23% divided by 100 means it is 0.3. Time duration 6 by 12, that is 0.5. So square root of 0.5 plus, take same as it is 0.5 into standard deviation 0.3 square root into 0.5. So 90 divided by 80, it is 1.125 plus 0.08 into 0.5, it will be 0.04 divided by 0.23 into square root of 0.5. Square root of 0.5 will be 0.707. So plus 0.5 as it is into 0.3 and square root is 0.707. So next, as it is, take ln 1.125 plus 0.05. Next, multiply all these three numbers, you will get 0.0813. Multiply these two numbers, you will get 0.16261. So after this, we need to calculate the value for this, that is the natural log. So for calculating this, I have already made one video on the working note. So before watching this video, you have to watch that video. So in that detailedly, I have explained how to calculate the value for the natural log. So after calculating that, we will get this value, that is 0.1178. So add that plus 0.04 divided by 0.621. So just add this to 0.1578, you will get, divide it, you will get 0.9704. Next, Add this 0.0813, the d1 will be 1.0518. So next we have to calculate d2. That is, it is given here. So d2, formula for d2 is d1 minus standard deviation into square root of time. So d1 is 1.0518, standard deviation is 0.23, and square root of time is 6 months divided by 12. So square root, so 6 by 12, it will be 0.5. So square root of 0.5 into 0.23. So square root is 0.701. So take 1.0518 as it is. 0.23 into 0.701 is 0.1626. So the final value of D2 will be 0.8892. So here till here we have solved D1 and D2. Next, what we need to calculate for simplifying this equation is we need ND1 and ND2. So already we have calculated D1 and D2. So next we have to solve this N. So need to calculate these two values. So ND1 means D1 value is, we have calculated here, D1 is 1.0518, and D2 is 0.8892. So N as it is 1.0518 and D2 0.8892. So let's take the first one, ND1, that is N into 1.0518. So N here means normal distribution. So for finding this, we need to see the normal distribution statistical table. So for this also I have made one video. So before watching this, you have to watch those two videos, two working notes. So here this value is divided into two parts. Why? Because in the normal distribution table, the values will be given only for two numbers. So here there are four numbers, so we'll divide this number into two parts. So it is 1.05 and remaining, that is 0.18. So here n equals 1.05 and plus 0.8. So here if we see the normal distribution, so 1.05 and 0.18. So this 1.0518 means this will lie nearer to 1.06 only. So this is 518, it is nearer to 1.060. So that's why we have to take here the most nearer above number. So that is 1.06. So this formula is for normal distribution, where n into 1.05, this one, plus 0.18, within bracket we have to take the above number, that is after number of 1.05, that is 1.06, again we have to less this number from it. So this is the method given by the BSM model for calculating the n values. So here we have to take the next number or the highest number of 1.05. So after 1.05 the number will be 1.06. So for this value, for getting the value for 1.05, we have to see the statistical table. So if you see the statistical table, the value will be 0.8531, and for this also you will get the value in the table, that is 0.8554. So here same, we have to take this value you will get in the table, take 0.18 as it is. This value you will get in the table. So this value, that is minus 0.8531. So take 0.8531 as it is plus 0.18. So if we deduct both this number, the value will be 0.0023. So at last 0.18 into 0.0023 will be 0.00414. So the final answer for ND1 is 0.8535. So like this only we have to solve the ND2. So ND2 is 0.8892. So divide this number into two parts, 0.88 and 0.92. Same method will be followed. First we have to take this first number n into 0.88 plus next number we have to take as it is. Within bracket we have to take the next number of 0.88. So 0.88, next number will be 0.89. Next we have to less the first number, that is 0.88. So this value you will also get in the statistical table. So 0.806, take 0.92 as it is. This value you will also get in the statistical table. So the value will be 0.8133 minus the value of normal distribution, that is 0.806. So next we have to simplify all this. The final answer will be 0.8131. So here we have simplified all the parts of the equation. Now we have to go to the final equation, that is C equals S. S is the 9, D, ND1 is 0.8535 minus K here means the strike price 80 into E means the log number to the powers RT minus 0.08 into 0.5. For this also I have made one video. You have to watch that video first. Next is ND2, which we have calculated. So 90 into 0.8535 minus 80, you will get this answer, that is 0.961. So multiply all these three, the answer will be 62.51. Less both the numbers, the final call option price is 14.3039.